could you solve this problem? It's a ladder against the wall problem. I came across this problem over 50 years ago when I was younger, and I thought it looked easy. So it's a ladder 9 foot long, leans against a wall, just touching a box which is 1 foot square. How far over the wall will the ladder reach? Well, here's a diagram. Now, I tried this, and it seemed easy at first. Then I got to a point where I could go no further. So I put it away, and then took it out again later on and tried it. And I could do this for quite a long time. I couldn't solve the problem until eventually I tried a different method. So my solution of the problem is here. You might want to try to solve it yourself first before you look at my solution. You might find an easier way, I don't know. But I know I found it very difficult. The first thing I did was to redraw it a bit and put some variables in. So we've got the height from there to there is x, from here to here is y. So the ladder is 1 plus x up the wall and 1 plus y away from the wall, which is there. Now we can use Pythagoras now. That was fairly straightforward, I think. And by using Pythagoras, we get 9 squared is x plus 1 squared plus y plus 1 squared. And if we solve that, we get x plus 1 squared is x plus 2x plus 1. Y plus 1 squared is y plus 2y plus 1. And if we put those all together, we get x squared plus 2x plus y squared plus 2y is 79. And that's what I called equation 1. The next step was to use similar triangles. Now, this triangle here is similar to this triangle here. So we can say that 1 over x is equal to y over 1. Or x over 1 is 1 over y, same thing. And we get y is 1 over x, or xy equals 1. So we put that in the first equation, which is this one here, and in place of y, we put 1 over x. So we get x squared plus 2x plus 1 over x squared plus 2 over x equals 79. This gives us this equation here. Now, if we multiply through by x squared, we get x to the fourth plus 2x cubed plus 1 over x squared plus 2 over x equals 79. And this was equation here, x to the fourth now, plus 2x cubed plus 1 plus 2x equals 79. That's where I got stuck. I couldn't solve this. Maybe you can, I couldn't anyway. So I had to try a different approach. Going back to equation 1 we have there, I just rearranged it a bit. So x squared plus y squared plus 2x plus 2y, which is 2 into x plus y, equals 79, equation 2. Now I tried a bit of lateral thinking, I suppose, and I remembered that x plus y squared is x squared plus y squared plus 2xy. And if I rearrange that, I get x squared plus y squared is this bit minus that bit, which is x plus y squared minus 2xy. Put that back into equation 2. Now we get x plus y squared minus 2xy plus 2x plus y equals 79. Now that bit there, xy equals 1, so that equals 2. Bring the 2 across to here, and we'll get this equation. X plus y squared plus 2x plus y minus 81 equals 0. And if we let x plus y equals z, we get this equation. Z squared plus 2z minus 81 equals 0. Now this is a quadratic equation which we can solve using the quadratic equation x equals minus b plus or minus the square root of b squared minus 4ac, all divided by 2a. In this case, a is 1, b is 2, and c is minus 81. So we'll put those values in here, and then simplify it a bit by taking t as 2 squared outside. Further down, and we get z is minus 1 plus or minus the square root of 82, which is minus 1 plus 9.055. I know that is also a minus 9.055, but we'll get a total minus answer, which is not applicable in this case. So x plus y equals 8.055. And if we go a bit further down now, we'll find that x plus 1 over x, because y is 1 over x, equals 8.055. And multiplying through by x, we get another equation, x squared minus 8.055x plus 1 equals 0. We need to use the quadratic equation again. In this case, a equals 1 and b equals minus 8.055 and c equals 1. We put those in the equation like this, and if we solve that, we end up by saying that x equals 7.928. And some more, I suppose, but that's as far as I wanted to go. Y is 1 over x, which is 1 over 7.928, so it's 0.125. So looking at the height of the ladder of the wall, we've got to add 1 to 7.928. This gives 8.928. And looking at the distance of the ladder from the bottom of the wall, we have to add 1 to this, which gives us 1.126. So the height of the ladder of the wall is 8.928 feet. We put these into the Pythagoras theorem again, and we see that we get a value of just under 9 feet. It's okay, because we've used values which are probably more decimal places, so I think that's pretty close. We could get closer by increasing the decimal places, but I think that's very close to 9 feet. So the height of the ladder of the wall is 8.928 feet. The distances from the wall is 1.126 feet. As I said before, you could try this yourself. Maybe you can find an easier method than I've used, but I know I struggled for a long time. Of course, there are two answers for the height of the ladder. It could be 1.126, and the distance from the bottom of the wall to the ladder could be 8.928, but logically I've got the ladder going this way up rather than that way up. I hope you enjoyed that. If you find a different solution, please let me know. Bye.